takes 1.3 seconds for the light of the moon to reach us. And that's after it's taken 8 minutes and 20 seconds for it to reach the moon and us, and for us to then see the bounce. No. It's mad, isn't it? That is absolute light bouncing off of an absolute sun. We're seeing it as it is. Right. Ignore the pyramid stuff. There was a storm coming over. And I started doing stuff outside, and then I saw myself doing this again. So what we're looking at is from there, just that stuff. Right? Right, that's all we're looking at. Forget the pyramid stuff. Now, remember when I used to say, when we're bringing things down to scale, right? So you bring things down to scale, everything's smaller, but to scale with each other, okay? Now, the first one I did was this. Remember this piece of wood? Right? It's the right way up. So we've got the sun. If the sun had a diameter of 3 millimeters, right? 3 millimeters, and we kept the distance between Earth and the sun, the 150 million, if we kept that to scale with a 3 millimeter sun, the distance is 32.4 centimeters, right? That's 108 sun diameters. So Earth would be here, right? We wouldn't see Earth because it would only have a diameter of 27 micrometers, and that is like a speck of dust that's smaller, okay? But that's with a sun of 3 millimeters. And then I said, because it's to scale, when I turn the sun on, we would expect to see the light take 8 minutes and 20 seconds to reach Earth, because it's to scale, right? It's a tiny, tiny sun, so, and it's to scale, right? But when I turned it on, if I can find, this is when it'd be handy to have another hand. Bang, right? That's what happens. There's the sun, bang, and it radiates instantly, doesn't it? So why is it not taking 8 minutes and 20 seconds to reach that Earth? If it's to scale, right? Yeah, but it's little and no, it's not right. It is to scale, right? It should take 8 minutes. The only thing that isn't happening, that should be happening, is light is instantaneous here, but obviously because it's smaller, I get that. But can you picture light taking 8 minutes and 20 seconds to get to that nail that's Earth? You can't. But that is how long it would take if we were watching it, because it's to scale, right? It's not my fault that you don't understand the to scale. Basically, if we took the sun out of the sky and we shrunk the sun down to 3 millimeters, right, the distance would go from 150 million to 32.4 centimeters. an Earth would go from 12,742 kilometers in diameter to 0.27 of a millimeter, 27 micrometers, right? Tiny. But everything is to scale. So we'd expect to see light traveling at 4.6 seconds each diameter of that bulb, because that's what the sun does up there. You're just going to have to deal with not understanding about the keeping things to scale thing, because it's a very, very basic concept, and I'm not, it's the fact that people can't understand this, it's scary. Now, using that same analogy, if we had a 30 centimeter diameter planet Earth, right? So we've got 30 centimeter diameter planet Earth. If we multiply that by 109, that's how many Earth diameters fit in the sun, right? So at 30 centimeters, we multiply it by 109, the sun would have a diameter of 32.7 meters, right? That's keeping everything to scale. Must understand that. It's keeping things to scale, right? So now we've got a sun with a diameter of 32.7 meters. Now that is like a 10-story building, right? 1, 2, about 3 meters in each floor, okay? Give or take, that's 10 stories. So that would be a sun. A sun the size of 10 stories, okay? Can you imagine that? Right? And now we multiply the diameter of this sun by 108, because there are 108 sun diameters between Earth and the sun. So we would get a distance of 3.5 kilometers, right? So to scale, a 30 centimeter planet Earth, right, would be to scale with a 32.7 meter diameter sun. That is the same as a sun that's got a diameter of 1,390,000 kilometers, and a planet Earth that's got a diameter of 12,742. This is exactly the same. It's to scale, right? It's to scale. And then we've got the distance in between Earth and the sun, 108 sun diameters. So if we multiply the 32.7, which is one sun diameter, by 108, that is the distance for 3.5 kilometers, 2.1 miles. Okay, so we've got a sun, right, with a diameter of 32.7 meters. We multiply it by 108, because that's how many there are in between Earth and the sun. We get 3.5 kilometers away. Right. If you turned at night time to look at a building, a 10-story building, right, that was 2.1 miles away, just only 2 miles away, 3.5 k's, and that building had a laser, the 10 stories, and it was facing you, and it switched on. How long do you think it would take the light to get to you? Instantaneous. Obviously, you can burn your eyes out, right? So this is exactly the same scale, to the same in proportion to the 3 millimeter sun, right, and a 0.27 millimeter Earth. Now, it was instantaneous down there, wasn't it, at that scale? And obviously, a sun with a diameter of 10 stories, right, that's only 3.5 kilometers away, it's going to blind you the second it turns on. Now, what we have, if we were the sun, right? If we were the sun right here, well, no, it would be further away. We would be in we are a 10-story building, right? We're the sun, 3.5 kilometers away, 2.1 miles away, and we're facing a moon and planet Earth, right? Now, put yourself into the situation. You're 3.5 kilometers away, and you are a 10-story building. You're a sun, and you're facing a planet Earth of 30 centimeters in diameter. That's 3.5 kilometers away. This is what would happen. It would be instant, right? That is to scale. The moon is a little bit smaller, right? Because we're a bit closer, and the shadow would have been a bit too big. Because if I go like this, see? Now, you can imagine this flashlight. If I move back, if I go back 3.5 kilometers, and the flashlight is really a sun with a diameter of a 10-story building, 32.7 meters. You know it's going to light that moon and that Earth up instantly from 2 miles away. Well, you can carry on multiplying the distances and everything will double, right? So if you times it by 2, the Earth becomes 60 centimeters in diameter, and the sun, it moves at another 2.1 miles away, so it's now 4.2 miles away, but its diameter goes from 32.7 meters, 35 yards, to 70 yards, right? Everything doubles. The distance will double, the diameter of the sun will double, and the diameter of Earth will double, and the moon. There will never come a time when if you keep doubling and keep doubling and keep doubling, it's never going to come a time when the sun is going to radiate its light any slower, right? You have to understand this. It doesn't get to the diameter of 299,000 kilometers and then suddenly take a second to radiate its light to planet Earth. It's illogical. The bigger the light source, the further it radiates its light, but at absolute speed. It's so basic. Let me zoom in on this. My bad, I should have done that straight up, but switched off, the sun switched on. From off, I think it will take 8 minutes and 20 seconds for a sun that's 2.1 miles away and that has a diameter of a 10-story building. Of course it's going to be instant, isn't it, to reach here? Boom! 2 miles away, 10 stories, like a laser pointing at us like the sun does. Keep doubling that distance, doubling the sun's diameter and doubling Earth's diameter, and you will never ever get to a distance that you would say, oh yeah, all of a sudden it's taking 4.6 seconds for this gigantic sun to reach planet Earth. No, it's illogical. The bigger the light source, the further it will radiate its light instantly. Bang. Right, peeps. The pyramids should sort themselves out.